All right, this is tape 264, which is double and half angle formulas. So let's look at some examples of the double and half angle formulas. Well, first of all, we're going to look at double angle formulas. Double angle formulas. And here are the two that you need to memorize. Now please hear me and watch the way you memorize it. What this says is that the sine of 2 times some angle, in other words, if I had a 36 here, then it would be 2 times 18. If I had an 80 right here, the sine of 80 would be 2 times 40. If I had a 6a right here, it would be 2 times 3a. The sine of twice an angle is equal to 2 times the sine of the angle, cosine of the angle. Or another way of memorizing this, the sine of some angle over here is 2 times the sine of half that, cosine of half that. Now this is called the double angle formula, even though sometimes it's looking like it's going the other way. But what happens is, where you use this more often, most of the time that you'll use this formula, you will end up having a sine times a cosine. If you have 2 times the sine times the cosine, it goes to sine of double whatever this angle is. Now the cosine is 3 choices. The cosine of twice an angle is the cosine squared of the angle minus the sine squared of the angle, or 2 times the cosine of the angle minus 1, or 1 minus 2 times the sine squared of the angle. These two come from this one. If I come back here and use our identities and replace sine squared with 1 minus cosine squared, minus times makes 2 of these. If I come in here and replace cosine with 1 minus sine squared, it gives me 1 minus 2 of these. So these two come from this one. It's just nice if you will recognize all 3. To get the job done, all you need to know is this one. And then you have to be able to use identities to switch it around sometimes. All right. Now let's look at examples, real simple little examples, just to get across what the rule is really saying. A lot of people misinterpret these concepts by algebra. They're looking at algebra concepts, and that's not what this is saying. Here's what it's saying. The sine of 44 degrees is equal to 2 times the sine of 22 cosine of 22. The sine of an angle is 2 times sine cosine, where this is half that, or this is double this angle over here. All right, the sine of 6 beta is 2 sine of 3 beta cosine of 3 beta. The sine of 10 degrees is equal to 2 times the sine of 5 degrees cosine of 5 degrees. Again, here's the way I would like for you to see it. The sine of an angle times the cosine of an angle times 2 is the sine of double this angle. The sine of an angle times the cosine of an angle times 2 is the sine of double this angle. All right? So 2 sine 4a is 4 sine 2a cosine 2a, because sine cosine of an angle is 2 times. Well, that 2 times that 2 makes a 4. Okay? Or in other words, I'm going to factor this 2 out here and make this 2 sine of 2a cosine of 2a. So this 2 sine cosine goes to the sine of 4a. And then this 2 is this 2. Don't be looking at what's here goes that, this 2 goes to that 2 out there. Don't be looking at that. It's the sine of an angle times the cosine of an angle times a 2 out in front. If you have the 2 out in front with it, then that goes to the sine of double this angle. All right? And that's the way you need to look at the sine of 2a. I'm going to work several more with sine rules, and then we'll go look at the cosine rule here in a minute. Well, let's look at the next example. All right. example 5 in the notes, sine squared of 6x. Well, what you need to look at is forget the square. What that 2 there means is actually this squared. So what is the sine of 6x? The sine of 6x is 2 times the sine of half that, cosine of half that. So therefore the sine of 6x is equal to 2 sine cosine. Now all of that's squared, so this 2 right here gets squared, that's a 4. This gets squared, and this gets squared. So if you have the sine cubed of some sine angle, then that will go to all this cubed, this sine, cosine, and the 2 cubed. So you'd end up getting an 8 out here, and then these would be cubed. All right, now, number 6 is saying this. What if I have that and I want to simplify it? Okay, I want to bring it back into a smaller function concept. Well, here's sine cosine, but I don't have a 2. You must have 2 sine cosine for us to be able to simplify this. Well, what I'll do is put the 2 in there and out front multiply by 1/2. What is 1/2 times it? Well, it's 1. So what I'm doing is I'm kind of putting in a 2 that I want and putting a 1/2 out there to take care of that. Now that I have 2 sine of 4a cosine of 4a, then that goes to the sine of 8a. Then that 1/2 is out in front. Now watch this. If this had been cubed, then I would have had to put a 2 cubed right here. All right? I would have had to have an 8 cubed. Then that would have been a 1/8 out in front. And so what would I had? I'd had 1/8 that cubed. Okay, so if I have to have this cubed, then what I'm saying is I have to have my 2 here in front cubed also. In other words, I need to have this all out here cubed. So I'm putting a 2 cubed in there, so out front I have to have a 1/2 cubed, or 1/8. Okay, now let's look at 2 or 3 more, again pointing out this same thing in terms of the powers. All right, so if we're looking at 7 and 8, okay, what do we have here? We have 8 sine cubed cosine cubed. Well, that's what I was talking about a while ago, is I'll replace that in parentheses cubed. Well, that's okay, and 2 cubed is 8. So what does this go to? Well, this goes to the sine of 2x. If that's cubed, then that's cubed. All right, number 8 is just to kind of watch numbers. I have sine cosine. I need a 2 out there, so I'll make a 2 out there by factoring a 6 out. I have now 6 times 2 sine cosine. 2 sine cosine. 2 sine cosine goes to the sine of double this angle. And that 6 is just out there and times that. All right, that's some examples. Let's look at some more examples. All right, looking at some more examples. What we have here is sine times cosine. Sine times cosine. But we need a 2 out here, so we'll do algebra and factor 3 out of that, make it a 2. And now we have sine cosine. Sine cosine of the same angle. Have a 2 out here, so that then goes to the sine of double this angle. And then we have a 3 out in front that stays there. What I'm trying to make a point of is if we have sine times cosine of the same angle, if we can get a 2 there, then all of that is replaced with the sine of double whatever this angle is right here. Then whatever's out in front stays out in front. All right, now let's do some expanding. So looking at 10, we're going to go the other way. For some reason, sometimes in math, you need to do this. One of the purposes we teach half and double angle formulas and trig identities in trig class, and we push them so hard, is because Calculus 2, you will use them over and over again. So the cosine of 6a could be expanded to cosine squared of what? 12a or 3a? Well, it's 3a minus the sine squared of 3a. All right, so we could have it like that. Of course, you realize that we could use the other 2. We could have said 2 cosine squared minus 1. Or we could have said 1 minus 2 sine squared of 3a. But the rule is cosine squared minus sine squared is the cosine of double the angle. Cosine squared minus sine squared is the cosine of double the angle. 2 cosine squared minus 1 is cosine of double the angle. 1 minus 2 sine squared of an angle is cosine of double the angle. All right, so that's that process. Well, let's look at the next example where we have, it looks like, well, why even fool with this? Well, you fool with this for the purpose of seeing and make sure you see what the rule is. The cosine of x could be cosine squared minus sine squared. Now, what is this angle right here? Well, this double is that angle there. This double is that angle. All right, so we could have that. Or, if we had wanted, we could have had 1 minus 2 times sine squared of x over 2. Or we could have had the 2 cosine squared minus 1. But it's this goes to double the angle. This goes to double the angle. So no, cosine squared minus sine squared goes to the cosine double the angle. All right, now let's look at number 12. Well, number 12, that doesn't look like anything. Well, what happens if I factor 4 out of this? If I factor 4 out of this, this becomes 2 cosine squared of 8x minus 1. Well, hey, that's one of the rules. 2 cosine squared of an angle minus 1 is cosine of double the angle. So I end up getting 4 cosine of 16x. Okay? Now let's look at some examples dealing with the half angle formula. All right, these are called the half angle formulas. Now here's what I want you to notice about these. The sine of an angle is equal to square root of 1 minus cosine over 2. Listen to that. Sine is square root of 1 minus cosine over 2. Cosine is square root of 1 plus cosine over 2. Memorize it that way. Now, what this is saying is that the sine of 6 theta is the square root of 1 minus the cosine of 12 theta over 2. Okay, that's what it's saying now. The sine of some angle right here is equal to the square root of cosine of double that angle. Okay, so the sine of 6 theta is 1 minus square root of 1 minus the cosine of 12 theta. That's what the rule is saying. Don't read it just like it is in the book. It says that the sine of some angle is equal to square root of 1 minus the cosine of double that angle over 2. Or read it the other way. It says here that if I have square root of 1 minus the cosine of 3x, then over here this is sine of half that, 3x over 2. But to use this, I must have 1 minus cosine over 2, square root of that. 1 minus cosine over 2. Then whatever I have over here, this is the sine of half that angle. Cosine then, same concept, simply cosine is 1 plus. That's the way you know this. They're the sine and cosine half angle formulas. Square root of 1 minus cosine theta over 2 or 1 plus cosine theta over 2. And the rule is that the sine of it goes to 1 minus the cosine over 2. Cosine goes to 1 plus the cosine over 2. All right? So memorize it that way in that concept. And now let's look at some examples. So looking at 13 and 14, what we have is the sine of 3 theta. Well, sine is what? Sine is the square root of 1 minus the cosine of over 2. Cosine of what? 6 theta. That is half of whatever's inside the square root. That is 1/2 of whatever's inside the square root. You see, if you get the concept down the way it's supposed to go, then you can double check your work. All right, cosine. Cosine, if I want to use this rule, cosine then is square root of 1 plus the cosine over 2. Now what goes here? Well, 3x. Why? Because that is supposed to be half of whatever this is. So whatever I have inside here, that goes to 1/2 of it. All right, that's the purpose of these problems, to get across to you the square root of 1 plus or minus cosine over 2 goes to cosine or sine of half the angle. 1/2 of whatever the angle is inside here. All right. Now, example 15 is a process that we have to know for Calculus 2 in a lot of problems. And that is the sine squared. What is the sine squared? Well, what is the sine of an angle? Well, it's 1 minus the cosine of what? Double that angle over 2. So the sine squared would be, I'm going to square this and I'm going to square this. So what happens is the sine squared of an angle ends up getting rid of the square root sign. So the sine squared of x is 1 minus the cosine of double the angle over 2. In other words, the cosine squared of 10x is what? 1 plus the cosine of 20x over 2. Now just the cosine would have been the square root of it, but if it's squared, then it takes away that square root. All right, let's look at some more examples. So looking at example 16. Okay, in example 16, we're having to do some algebra to get where we want. For instance, we have the square root of 1 minus the cosine of 5x over, whoops, it's got to be a 2. It's got to be square root 1 minus the cosine of an angle over 2. So what we'll do is do algebra here. We'll factor this 18 into 9 and 2. What is the square root of the 9? Well, remember now, this is the only denominator, so that comes out in front. Square root of 9 is 3. And we have 1 minus the cosine of 5x over 2. We now have what we want. We have the square root of 1 minus the cosine of 5x over 2. That goes to, all of that is replaced with the identity, the sine of 10x. The point of this example is you've got to make this work out. Okay, you've got to get this where it's the square root of 1 minus cosine over 2. You can't have anything but a 2 here. It's got to be 1 and a minus or 1 and a plus. It's got to be cosine. When you get that, then that's how you handle it. All right, let's look at example 17 in terms of having to do some other kind of algebra to get the job done. Okay, so 17 we have here. Okay, don't have a square root in the bottom. I mean a 2 on the bottom. Do not have a 2 on the bottom. So what I will do is multiply the top and bottom by the square root of 2. Now this is a 1 right here. So I'll multiply the top and bottom square root of 2. So the square root of 2 on top and the square root of 2 on the bottom goes into the denominator. In other words, this would be like the square root over the square root. But the square root over the square root can be written as just the square root of all that fraction. We now have what we want. We have a square root 1 plus cosine over 2. So therefore, the square root of 1 plus cosine is cosine of double that angle. All right. This concludes then the tape 264 on double and half angle formulas.